Oh, hello everyone. It's August 31st. Well, I think today I spent, like 5 hours or 6 hours filling out an application for a job. That was one of the rather interesting experience. I mean, usually I didn't even do a cover letter or usually feel very, annoyed answering the question of, why do you want to work for us? And this company has the audacity to ask, I don't know how many questions, like 10, more than 10 questions, and each one requires quite some efforts to answer. The audacity of doing that. You know what? They got some balls, and I admire that. I like that. So look up the company in more details, and wow, they are doing. I don't really know what they're doing, but the company does have a very special culture, which I hope is real. I mean, it's at least on the surface, right? The way they do their first screening on applicants, the way they do their interviews, the way they compensate their employees, everything screams a certain type of culture that's very different from what normal companies do. And yeah, it's intriguing. I mean, I am always inclined for these weird type of things, and I'm interested. So I answered all the questions in very high detail. And as I went through the questions, they were not that bad, honestly. I mean, there was some, like, oh, they still have that, why do you want to work for us? This type of questions. But more importantly, it helped me review the past 4 years. And after I transitioned to this current kind of career, yeah, you see how you have changed, erred, made mistakes, and grown. All the questions as I went through them, it helped me kind of analyze all that. So yeah, I'm actually happy about spending those hours. Well, it'll be even more. I'll be even more happy if they extend an interview. But the stuff I wrote down, those were real stuff that I've gone through and I've done, and I'm quite proud of what I did. Hey, but the journey doesn't stop here. The journey will, continue forward, and the next step is to solve this problem. I think they're kind of obsessed with hard problem these days. All right, let's see if this one is interesting enough. Minimum number of tabs to open to water a garden. There is some type of range intervals type of stuff. A one-dimensional garden on the x-axis. Doesn't really matter. The garden starts at 0 and ends at n. And the length is n. Okay, there are n plus 1 tabs. So 1, 2, 3, 4, 5. So 5 plus 1, 6 tabs. At point, given an integer n and an array ranges of length n plus 1, where ranges I, means the ith tab can water the area I minus ranges I and I plus ranges I. If it was open, return the minimum number of tabs that should be open to water the whole garden. If the garden cannot be watered, return -1. Very interesting question. So it's similar, right, to all those. Basically, you're given the ranges, right? You're given the ranges, and you're asking the question of what's the minimum number of ranges to cover from 0 to n. That's it, right? That's what the question is asking about. Now, we have very limited examples. So the first example we have is, we can compute, all right? We can compute the ranges. So the first one, at tap 0, right? So at tap 0, range minus 3 to 3. So minus 3 to 5. Yeah, 1 to 3. I already have given you all the ranges. That's easy to compute, right? We can compute these ranges. All right, so now the question is, what's the minimum number? You choose these ranges, and you want a minimum number of choices to cover the entire thing. And then one, we want to cover is from 0 to 5, right? That's the one we want to cover. So, first idea, usually we'll sort them. Okay, and then this is actually already sorted, right? So we'll sort them, and then what? Then what? So you want to know if how many do you need to cover the entire thing? Huh? What do you think? Like, if I take the first, then we need to cover the entire thing. So we need this, right? No. Hold a second. So if I choose minus 3 to 3, and I choose 4, that's not gonna work because we have a range. The entire thing has to be covered. So it has to start at 3. So right, if this, we can binary search, right? Then we know if I choose 0, well, if I choose minus 3, 3, right? Then next we have to choose 2 to 4, right? 2 to 4. And if I choose 2 to 4, the next we have to choose is 4 to 4. And if I choose 4 to 4, I have nothing to choose from, so this is not going to work. So this means choosing this is not going to work. So I choose this. So what I'm saying is, you just start choosing, right? For each one, I choose this, and then I say if I start from, so the question is if I have many that starts at the same spot, right? If I have multiple starting from the same spot, they extend to a different end, right? If they extend to different end, the goal, right, is to they have to go through every single one. That creates an issue. What if we sort by ends first? Usually, you either sort by the front or sort by the end. I kind of sort by the front. It's not going anywhere. Right, if the front is the same, I have different ends. And which one should I use? Should I use the smaller end? Should I use the larger end? You cannot say. So if I sort based on ends, now I have end and I have different starts, right? Now I have different starts. If that's the case, well, the first thing we'll try to figure out is, do we cover the last one, right? Do we cover? If it does cover, yeah, this kind of has the same, let's say, same problem, right? Has the same problem. If we cover, we can find out, okay, what's the front of this thing? Then I'll have a bunch of them that I can choose from. I have a bunch of them I can choose from. And I need to choose the one that extends furthest. Because the further they extend, the more you can choose from. So again, if we go back to the idea of sorting based on the front, right? Sorting based on the left. If we sort based on the left, okay? I mean, if you sort based on the left, that's not what we want. What we want is to find the one extend most to the right. Right? We want to find the one extend most to the right. We find a one that extend most to the right. So in the start, we shall find one that cover 0, right? Shall find the one that covers 0 and extend most to the right. So what we need to do is everything that covers 0, we can make a list, right? We can make a list. And then among those, we find the maximum, okay? So that extend, perfect. Now, what we need to do is everything starts, but this is kind of a greedy, right? This is kind of greedy. What we're trying to say is at each step, we want to find the one extend the most to the right. And then within all the possibility, we find the one that extend most to the right. So every time we try to extend most to the right. Okay, this is kind of the greedy idea. We need to prove that it works. So let's say if we have something that doesn't extend mostly to the right, and that will give us the minimum number of taps, right? So it's a certain step, we find something that doesn't extend all the way to the left. So if it doesn't extend all the way to the left, then in order to cover, then the next tab will have to be, a little bit to the left. And that will also be covered by the first one. So because of this, I think the greedy idea will work. Okay. So basically the question is convert to this. Given the rightmost, given the current rightmost reach, given the current rightmost reach, let's call it RM, given this RM, we want to find the next RM such that its left is all smaller than the current RM. That's what we want to find. In this case, the first one, we start RM equal to 0, So we need to find all the left that's smaller than 0. In this case, it's these two. Okay? When we find these two, we need to find the maximum of this. And that will give us 5. Once we get 5, let's just suppose it has a lot more, Once we get 5, then we need to find everything that, because it's ending at 5, Ending at 5, start at whatever. So we want the next range to be like this, So the right has to be larger than 5. So the high need to be larger than 5. And the low need to be smaller than 5. So we need to search for all these. Oh, how are we going to search for all this? there a easier way to make this type of search? Yeah, so it's like a two problems. First, we need to do a search among the ranges, right? A search among the ranges. Given a right max or right, the most right that we can go. So given a value, so we given value, we want to find all the ranges, okay? Given a value, we want to find all the ranges. Find all the ranges such that low is smaller than val and high is larger than val. How do we make this? Now, low smaller than val, we can binary search. High larger than val, if we sort based on high, we can do binary search. All right. And then we need to do the intersection of the two, which, no, I don't think this is the right way, right idea to go. But if not, what else can we do? Well, the range is I is from 0, so the worst case is going to be 0. So they're always going to be, the star will always going to be larger or equal to 0. Okay. Yeah, that was the issue, right? What if something can extend beyond? Well, because each one is minus its range and plus its range, right? So the range itself also determines how large this whole thing is. Maybe we can sort based on ranges. What do you think about that? If we sort based on ranges, then we have one with the largest range. Well, because we want a large range. So we have the first largest range, right? Okay, now we have the second largest range and the third largest range. And then they all have how much they can cover, right? They all have how much they can cover. But then what?